Good morning, everyone, and welcome to the Flax Plant Along. Before we get started, I would like to take a moment to introduce your webinar team, Lisa, Anita, Jocelyn, Lee, and myself, Rebecca. If you have any questions during the presentation, please type your question into the chat box. Lisa and Lee will be monitoring these questions and will ask them as each question period comes up. Now, please allow me to introduce our guest this morning. Kat Haggart is a spinner, weaver, based in Waterdown, Ontario. Kat loves everything about flax, from the beautiful flowers to the hand of the finished cloth, and is excited to share the steps taken to produce versatile, durable, and beautiful linen. You can follow her on Instagram at cat_the_flax_lady. In this live Zoom webinar, Kat will be sharing with us her techniques for retting. Good morning, Kat, and welcome.
Hello, and welcome to everybody who's here. I am going to be talking today about retting in our second to last session of our OHS 2021 Flax Plant Along. It's hard to believe that we're almost near the end. This is a big presentation, and there's a lot of information, so there's still going to be opportunities for asking questions, of course, but I'm going to be talking a lot. So let us begin. Wake up my PowerPoint. Today's agenda is going to be talking about retting, of course, what retting is, when you're going to be retting your plants, what different types of retting, forms of retting that you can do on your own. How do you know when the ret is finished? That's the million-dollar question. And then how do you store your flax after you ret it? So here on the screen, I have a few pictures. The long one on the left is flax that was taken out of my retting tank. You can see it's still wet, but you can see the fibers are starting to come away from the flax straw. On the top right picture, you see some of my flax that I had in my retting pool last summer. And one of the critters that was living in my flax. So that is, as best as I can tell, an eastern Dobson fly larva. And they're great insects. They're top of the invertebrate food chain. They eat black fly larvae and caddisfly larvae. They indicate that your water's not polluted, but they also have really nasty pinchers. and as I was picking them out of my flax, one gave me a pretty nasty nip. So this is yet another reason to wear protective gear when you're working with your flax. I spoke about that a little bit last time. In this case, probably rubber gloves would have saved me from a little nip. However, no Dobson fly larvae were killed in the process, despite pinching me. They all got sent back to the pond. The picture on the bottom right is some flax that was being ground retted. And you can see the flax fibers coming away from the straw there. Okay, so I'm going to start off by talking about what is retting. And first of all, to me, it's the scariest part of the entire flax growing process, because it's there's no going back. It's like walking to a cliff at night and then stepping off by mistake. And if you step off the cliff, your flax is toast. There's no recovery after it. So I find it really scary. That picture on the right is some flax that I had over-retted. So that particular bunch of flax was with a batch that I was retting in a stream. And I had had really good luck retting my flax in that stream in previous years. But when I went down on that particular batch to check on it, and I went down early, a couple days earlier than previous years had finished the ret, I found my flax looked like this. So it had been eaten away. The flax was totally coming away from the fiber. The fiber was coming away from the stalks, and any fiber was in short little bits. So it was ruined. It was nothing but a cautionary tale to me after that. So that's why it's so scary. So what we're doing is we're going from flax that looks like the top left picture. We have a cross section of a flax stalk there, taken under a photo taken through a microscope. And the flax fiber is these bundles here. that are kind of glued together in clumps. So each hole is kind of the center of a flax fiber, and a whole bunch of them are glued together into a flax bundle. And these flax bundles run from the root of the plant all the way up to the tip, all around the outside of the plant. So here you have the outer edge of the flax stalk, and here's the center of the flax stalk. So this is dried flax, but not retted. What we want to get to is this picture on the bottom. So here you have the flax bundles. Again, you can see that they're really not connected to the rest of the flax plant. And the individual flax fibers are even beginning to separate from each other. So this is the aim of retting, to go from this to this. If you overret, what happens is the processes that separate the bundles from the rest of the stalk continue and start working on the fiber strands themselves. Those are more resistant, but not impervious to the action that's going on during retting. So eventually they will be broken down and worn away as well. So that's what happens with over-retting. So what we're doing, excuse me, let me go back. What we're doing is we are enlisting bacteria during the retting phase, and we're getting them to eat the fermented pectin. And when as anybody who makes jelly or jam knows, pectin is added to make sure that the jelly or jam has a nice set. It keeps it nice and still. So it's kind of like plant glue, and it occurs naturally to various degrees in most plants. We want to remove that plant glue so that the fibers separate. So there's various types of bacteria and organisms that will do that to help us. There are roughly 3 phases where that happens. The first is that we put the flax in conditions where the flax is moist or wet. And that causes the pectin to start to ferment. And so fermented pectin sounds like a real party to the bacteria, and they come and find the pectin in the second stage of retting. So we're attracting the bacteria, and then they start to eat away at the pectins and other compounds in the flax, and that is what's happening in the third phase of retting. Is they're actually actively eating away at the pectin. And then what we need to do is we need to stop that process before they get all carried away and eat our fiber as well as the things that we want them to eat. So that's what's happening during retting. So the next question is, when do you ret? And the kind of facetious answer is, well, after you harvest it and before you process it, just ret it. But you can ret the freshly harvested flax. So on the left, you see a picture of flax that has had its seed bolls removed, like we talked about in our last session. So you can start retting right at this stage, or you can store your flax indefinitely at this point until there's a time that's more convenient for you to ret the flax. So you can ret basically at your convenience after the seed harvest. You can also ret flax that has already gone through the retting process once, and that's my slide on the right. So this makes my answer to the question of when to ret a little bit more complex. So if you've already retted your flax and you find that you were overly cautious and took your flax out of the retting process a little too early, and the processing isn't going that well, you can restart the retting process. So as my note says there, it was retted once already, and in my judgment, it needed about at least 6 more days in my pond before it got to the stage where it processed easily. and there were 15 bundles of that. So my normal workflow for flax is after I harvest the seeds, I do ret, and then after I let it dry, sometime over the winter, I look at each bundle and I judge how good the retting process went. And for those bundles that are completely retted, I set those aside as ready for processing. And then the other bundles I set in different groups, needing additional processing. So this particular group of bundles was were the ones that I thought needed just shy of a week more processing in my pond. So the next season, then I would do that additional ret, and you can re-ret as long as you need. So the good thing, while over-retting is really scary, the good thing is that under-retting is not harmful at all. So you can take baby steps to approach the proper ret until your flax is in a good place for processing. Okay, so types of retting. So there are a number of different ways that you can ret. I don't know of many people or places that currently ret mechanically by just whacking away at the flax until the fiber separates. Chemical retting and using enzymes to ret are typically used by large industry. And in this table, you see the type of retting on the left, some conditions in the center, and then how long it takes on the far right column. So chemical retting can take an hour, no more than an hour and a half, which is very attractive for large industry, because that means that they can fit the production into a process, and a short process at that. So that's attractive for a number of various business reasons. Enzymes are also fairly short. Takes half a day to a day using enzymes. Again, relatively short. They don't have to build a lot of infrastructure for maintaining or holding flax during the processing stage, and they can still keep up a good turnover. I have heard of some smaller producers using enzymes, but not very, very many. So ground retting and water retting are methods that are mostly used by producers of our size. Small scale or hobby producers of flax will typically ground ret or water ret. So when you ground ret, you're laying your flax on the ground. The moisture is supplied through dew or snow, and it takes anywhere from 6 to 14 weeks to ret your straw ret your flax using that method. Water retting, there's a number of different avenues for that. There is open water or flowing water retting, I should say, through if you're retting in a stream or in a river. That could take 2 to 4 weeks, although in my experience, sometimes it takes much less than that. As my experience with my over-retted flax shows, who knows what's going on upstream of you. If farmers have been putting stuff on their field and it flows into the stream and then hits your flax, your ret might go really fast. So there's lots of variables with a stream or a river ret. Pond or lake rets with larger bodies of water take about 1 to 3 weeks. And if you have a tank or some kind of water or holding device in your yard, that can take anywhere from 4 to 14 days to ret your flax. Okay, so ground retting. So ground retting is an option that's available to just about everyone. You're going to be laying your flax on the ground, but not on the soil. So you don't want, when you ground ret, you don't want to let your flax touch the soil, because you're going to end up with decomposed flax, but not in the way that you want it to decompose. So it'll get mildewy, it'll deteriorate relatively rapidly. So that means if you're ground retting in the warmer months, you want to lay it on grass. And if you're ground retting in the winter, you want to make sure that you have a good base of snow so that if you do get a warm period and it melts, the flax doesn't settle down onto the muddy ground. And moisture needs to be applied regularly. So in the case of ground retting on grass, if you're in the spring or maybe the fall, and you have dew regularly on your ground, then you don't need to do much more than that. If every morning it's damp with dew, you're good to go. If it does get drier, you need to moisten your flax with water from a hose or a watering can or something like that to keep the moisture there so that the pectin can ferment. About once a day, you'll be flipping and moistening your flax. The reason that you would be flipping your flax if you're retting on grass is because the side of your flax that is facing upward is going to dry out from the sun and the wind, and the side that is toward the ground is not going to dry out. If you leave it in that configuration for the whole ret, it's going to ret unevenly because the bottom flax will stay moist. The conditions are going to be quite different. So the way you handle that is every day you flip it over so that what was on the grass side is now on the sun side. And so that'll dry out and the side on the bottom will stay damp through the day. So with dew retting, you're going to provide even moisture by flipping it daily and making sure that it's damp, whether you had dew or whether you need to supply the water. If you opt for snow retting, then typically more snow will fall on top of it, and so there will be moisture provided by the snow on top as well as the snow below, and so no flipping is required. The snow will provide the required moisture. One piece of advice that I have heard about ground retting is to repeat the process in the same location year after year. And the reason for that is that some of those bacteria, after their job is done, will migrate into the soil and hang out there. So that the next year you ret on the ground, the bacteria will be nearby and the process will start more quickly so that the ret will take less time. So that's the reason for that advice. So I have a little video here that shows me laying out some flax for ground retting. So for ground retting, I don't have my flax in bundles anymore. I lay it out in an even layer with all the roots on one side, tips pointing the other side. But you need a fair amount of space for this to accommodate the flipping, as you'll see when I get to it. So I'm not going to lay out all that flax, just a little bit more to show what I'm talking about. So here I am, I'm cautioning you, not just this width, twice that. And now I'm going to show you why, because every day when you flip it, this is what I've found to be the easiest method of flipping the flax. And so when I do this in longer rows, I don't duck walk along. I usually, instead of my hand flipping, I'll use a stick to slide it underneath and flip it over. So that's ground retting. Okay. I'm going to talk about water retting and then I'll open it up for questions. So if you're burning to ask questions, there is a question period coming up very soon. But first I want to talk about water retting. So there's three main forms. If you remember that table of water retting, there's the flowing water retting through a stream, and that's the picture on the top right. There's like an open body of water like a lake or a pond, and that's the picture on the bottom right. And then there's retting in a tank, which is the picture on the far left. So if you have a stream that you can ret in, there are some considerations. In this case, you're going to want to keep your fiber in bundles. And that's because you don't want, because it's less likely for your flax stalks to float away down the stream if they're bundled together. So you start with your bundles, and then somehow you want to anchor those bundles to the stream bed. Again, you don't want the whole bundle floating away, and especially if there's a rainfall during your ret and the stream picks up speed, you want it to be secure enough that it's not going to float away. So once it's anchored, you also need to submerge your flax. So you're going to be keeping it underwater so that the anaerobic bacteria have a chance to work. So in the picture on the top right, you'll see that they used boards to hold the flax and then rocks on the boards to keep it submerged. And I'm not sure whether that was also their anchoring system or not, but that's how they handled their stream ret. If you are water retting in a pond or a lake, again, it's a good idea to keep your flax in bundles. So because things can dislodge your flax and you don't want it to float off into the middle of the pond or off into the lake. And again, you're going to want to submerge the flax. So depending on the bottom of your lake, if it's really mucky, you don't necessarily want the flax to be settling into the mucky bottom of a lake, but you do want it submerged. So in my case, when I was pond retting, my pond was my pool. You know, in the fall, we would cover the pool, and then over the winter, snow would fall, rain would fall, and water would collect on top of that cover. And that's what I used as my retting pond. So that's my pond in the bottom right picture. When I put my bundles of flax in the pond, then to keep them submerged, I kind of gathered them and made sure they were underneath an old screen door. And I had been hoping that that would be enough to push them under the surface of the water, but it was not. So I had a piece of lattice lying around, and the weight of the lattice was enough to keep everything submerged. So once again, you're looking for keeping it handy, and also you're looking at ways to keep it submerged, and then you're going to continue with your ret in the pond. So tank retting gives you the most control over all the forms of retting, water retting, I should say, and because it's smaller, it's handier, and you can control more of the environment. In this case, I don't have to keep the flax in bundles, and the advantage of that is that the flax is accessible. Even the flax in the very center of the bundle is readily available to the bacteria to get to them. Sometimes if a bundle's really tight, it's a little bit protected from its environment, and so it takes longer to ret. And you can lay your flax out without bundling it in a tank like this, because it's not going to fly away anywhere. Okay, so the 3 types of retting. This is me getting some bundles ready for my pond retting. So I use jute twine for this because I can compost that after. And I bundle the flax up into bundle sizes that are not too big for a couple of reasons. First of all, a smaller bundle won't have as much flax in the very center, where it's harder to reach. So my bundle sizes are about the size of a loonie, I'm showing you there. So with a smaller bundle, the inner flax rets just about as quickly as the flax on the edges. And the second reason that I like this size is that I then just use this entire bundle in my processing, and that is a good way for me to hold on to the flax when I'm processing it. It's not too big for my hand. So you see, I just tossed my flax bundle into the pond. The next step would be to gather it together and then sink it. Okay, so one more slide and then questions. So now I'm doing a little bit of a comparison between the controllable tank environment and a stream, pond, lake environment. So for a tank environment, what I mean is it can be a kiddie pool, it can be a tarp that's has the shape of a tank underneath it to provide a tank-shaped space, very, very temporary. It can be a kiddie pool, it can be an animal water trough. So the requirements are that it be long enough to hold the flax without bending the flax, and deep enough to submerge it. So it doesn't have to be very deep, just deep enough for it to be underground, or underwater, I should say. So with respect to bundling, you don't have to bundle it in a tank, and you get a more even ret. In a stream, pond, or lake, you should bundle it so your flax doesn't drift away. Now, water temperature, apparently the ideal water temperature for retting is 80 degrees Fahrenheit. And with a tank, it's possible to control that. I've heard of people putting animal water heaters in the tank. These are the heaters that they use in animal troughs through the winter to keep the water from freezing, but they use it in the summer to bring the temperature up to 80 degrees. Some people will also put straw bales around their retting tank to keep that temperature high. That's not something that I tend to do. A lower temperature means that it takes a little longer, but to me, that's a bit of an advantage because it allows life to happen. And if I get distracted, then I have a little bit more leeway to avoid over-retting. And I don't mind adding a day or two on to my retting procedure. I would rather do that than fuss with a heater and straw bales and things like that. But everybody's different. Of course, you have no control over the temperature when you're using a more natural source of water. So as the bacteria are working in the ret, they're excreting waste. So just like if anybody makes their own wine, the yeast that is creating the wine, it's eating the sugars in your fruit juice, eats the sugars, excretes alcohol to make your wine, but eventually the yeast kill themselves because they die once there's too much alcohol in their environment. The same thing will happen in a retting pond. If the bacteria excrete too much waste and there's not enough fresh water, they're going to poison themselves. So in a tank, you need to remove the waste and renew with fresh water. It's relatively easy to do because the wastewater floats on the surface over the clean water. And so you can remove it using a bucket or siphoning it off the top, or some people add fresh water at the bottom and it lifts the whole water level and the waste kind of spills over the edges. So that's how they control it. If you're in a stream, pond, or lake, you don't have to worry about that. Either the stream is going to carry the waste products away, or the pond or lake is so big that the waste is not going to change it too much, and the bacteria will still be able to do their job. The next consideration is colonization. This goes back to my picture on one of my first slides of the Dobson fly larvae. When I was stream retting, I would bring up my flax bundles and they would have crayfish in them. In my pond retting, there would be insects in them, sometimes tadpoles in them. It's a good environment for a lot of critters. It's very safe and protected for small animals, and so they like it. You're not likely to find that in a pond environment. It's there for in a tank environment. It's there for too short a period of time. Even mosquito larvae aren't going to be able to get going in your tank with you changing the water all the time. But it is quite likely in a stream, pond, or lake, so just be aware of that. pH is a method of telling how the ret is going, and I'm going to be talking about that in a bit. You can test the pH of your retting water in a tank, but you can't do that in the more natural settings. So that takes away one of your tests for the ret being done. And then things that you have to do while it's retting. In a tank ret, you have to replace about 10% of the water every 12 hours. That's about the rate that the waste needs to be changed, and you don't have to do that in a stream, pond, or lake. Okay, so we're going to stop for questions. So do we have any questions in the chat?
Hi, Kat. Yes, we have a few.
Okay.
The first one is looking to see whether, to confirm, when do retting, you take the flax out of the bundles and it lays loose on the grass.
That is correct.
Okay. The next question, when you say you can ret right away after harvest, does that mean that it isn't necessary to dry the bundles? If we do have to dry the bundles, how dry should they be before retting?
Okay. So the one of the main reasons that you want to dry your flax after harvesting is to harvest the seeds. So in order for the seeds to continue ripening, you let the flax stalks dry. And so that the plant takes the energy that's still in the stalks and sends it to seed production, so that you go from a low count of viable seeds to a high count of viable seeds, so that you maintain your seed production. If you don't care about the seeds, I don't know whether or not that, and you start the ret right away with the green flax, I don't know whether or not that will affect your ret. I haven't read any studies that do that. Everything I've read says to dry the flax first and then ret it. So I don't know if that's mostly for seed production or if there's other reasons why you shouldn't. So until I do some more experimenting myself, I would say just go with the wisdom of the flax producers and dry the flax. Actually, I should say the second reason for drying your flax after harvesting is also for storage. So in case you don't have time to ret right away, you need your flax to be dried properly. Otherwise, it will rot when it's in storage before you get to ret it. So I hope that answers the question. Another question?
Okay. Thank you. Yes. The next question is, should I separate the slimmer stalks from the thicker stalks and ret them in separate bundles?
That is a very good question. The flax stalks do ret at different rates. And it was a surprise to me. The ones that ret faster are the bigger stalks. So if you have the patience to separate them, then you might want to do that, because your ret will be more even. If you have all the fat ones in one bunch of bundles and all the skinny ones in another bunch of bundles. Having said that, the difference is relatively slight. So it's well within the tolerance of unevenness that can come due to it being in a bundle, or if you do different bundles in different batches, that variability is all going to be there. So short answer is yes, it can make a difference. The longer answer is, for me, I don't think it's worth my time to separate the stalks in order to erase that difference. The average works well enough for me.
Okay. The next question is, do you know if turtles would eat the flax in a pond?
Would turtles eat the flax? They might. I have a turtle. She's a little picky. I don't think she would eat the flax in my pond. She really likes duckweed, but not flax. But they might. They'd probably be more likely to go after something that's easier to eat. Turtles don't have teeth. They just have a kind of a hard ridge in their mouth that they use. And flax stalks are pretty tough. So I don't think that they would be able to bite through the flax easily enough for them to make it worth their while to eat it. So I think that, and when I have things in the stream and there's critters in them, it's mostly for the protection, not because they've been eating the flax. So I wouldn't be too worried about turtles.
Okay. Next question is, how much flax can we stuff into a kiddie pool?
You want to, depends on the size of your kiddie pool, but what you need, that flax can go right to the bottom of the kiddie pool. So that's fine. You don't have to worry about muck on the bottom getting in there. You're going to want to have at least 6 inches, I would say, of water between the top of your flax and the surface. Keep in mind that the more flax you have in there, the more food there is for the bacteria. The more bacteria there's going to be, the more waste products there's going to be. So you might, if you stuff your tank really full, you might need to replace more than 10% of your water every time, so that, especially later in the process when there's more bacteria, so that there's always fresh water for the bacteria to live in, and so that you're replacing your waste. Retting in a tank takes about a week for me. And that's not that long a period of time. For the amounts of flax that I am processing myself, I would rather have several different batches that I'm retting than to do it all in one batch, because it's easier to maintain the water when there's more clearance of water. And also, it's not putting all of my eggs in one basket. So if I over-ret, I'm not going to be over-retting everything. I'll just be over-retting a small. So I wouldn't advise you to overload your tank. Okay, more questions?
Okay. Yes, I have 3 more. Can the waste be composted?
The waste of these bacteria is acidic. And so you can definitely take that waste and put it on plants that like the acidity. So some hydrangeas, you might get some really good colors on your hydrangeas. Well, actually the hydrangeas are blooming now, so it might be a little too late, but you would be making the soil more acidic for future years. Blueberries, I think, like acidic soil. If you have plants that are sensitive to the acidity of the soil, and they don't like acidity, I wouldn't put this water on those plants. So, or like if you want to water with it, if you spread that water widely and then maybe do some regular watering, then it might help. But remember that it is acidic. So you're going to a pH of about 4, which is around the region of acid rain. So it's not that great. Also, putting acidic water on leaves of plants is not that great either. So the answer is maybe.
Okay, thank you.
Next question.
Will chlorinated water impact the retting?
Okay, a lot of people like to use rainwater. And I start my rets with Hamilton Tap. It's great to drink and it's fine for my ret. It will slow it down a little bit because there are chemicals in there. There's the fluoride for your teeth. There's any remnants of chlorine or whatever the water treatment plant uses to purify the water. That evaporates fairly quickly, and I don't find that it slows my ret down too much. So I just use tap water. Similar considerations apply to well water that's been conditioned. So you're adding salts to the water to condition it. Again, it might slow the process down a little at the beginning, but I find once it gets going that it's still fine. It's fine to use that water.
Okay. Does ground retting kill the grass it's laying on?
It does not, because because you're flipping it. It's not going to shade it for long periods of time, and it doesn't hurt the soil. So you're not creating the kind of acidic environment like in the water when you're water retting by dew retting. Everything is a lot less concentrated, and so it doesn't hurt the grass. I don't do it that often, partly because my husband doesn't like to see straw strewn all over his grass, and he doesn't appreciate having a strip of long, like 2 weeks, 3 weeks worth of grass when the rest of his lawn looks more nicely manicured. So that's just a compromise that we make, but it's not hurt it. Yeah.
Okay, I can understand that too in my house. Last question, is there a danger to replacing too much water?
No, if you the bacteria are going to be hanging around where the fermented pectin is. So they're hanging around the bar. If you're taking your water out near where the flax is, you might be sucking some of them out. But if you try to take your water out near the surface, or if you use the overflow method, then it shouldn't slow your process down too much.
Okay, great. Thank you. That's all the questions for now.
Okay, that's great. So the big question, when is it done? Back in the day, there was a lot of knowledge that was passed down from person to person about all sorts of things, including retting flax. So we don't have that so much anymore. But what we do have is a lot of really smart scientists, and they have studied the retting process and kind of scienced it out. And that's how we know about the different pH levels. And so the scientific method to determine whether flax is done is to use a controlled environment. Scientists like controlled environment because as many variables as they can exclude, the better, as far as they're concerned. And in that environment, you can use pH to judge how the ret is proceeding. The bacteria excrete acidic waste. And so if you're using pH paper, if you're using a regular pH paper, you want the blue litmus paper and not the red litmus paper. Red measures the alkaline side of the pH scale and blue measures the acid side of the pH scale. So blue litmus paper is what you want to use. So what's going to happen is when you start the ret, your pH is going to be the pH of your water. So that's going to be 6.8 to 7 is about the average pH of regular old rainwater or tap water. As the process begins and continues, that pH is going to lower. And it's going to go down to about 4.5 to 5, and you're going to be checking every 12 hours, so morning and evening. And it's going to continue dropping and dropping and dropping till it gets to about 4.5 to 5. It's going to level off for about two measurements. It's going to stay at around the 4.5 to 5 pH level, and then it's going to start becoming more alkaline. So your pH numbers are going to be getting higher. You want to take the flax out at the end of that level period at the bottom before it starts becoming more alkaline again. That's a sign that it's over-retted. So this is a very busy slide. I'm going to let your eyes have a bit of a chance to adjust to all that's going on that screen. So these are the pH papers that I'm using. It's not pH paper, it's tab pH markers. And I think that I'd like to try just a regular blue litmus paper, because I found that with these tab papers, excuse me, they all faded to white eventually. So I couldn't keep them as a record unless I took a photograph like I did here of what the pH paper told me. 2 days later, I couldn't go back to reference it, but it's my understanding that with a regular blue litmus paper, it stays the color that it changes to, and then you can write on the piece of paper what the date and the time is. So I am going to be buying some blue litmus paper for myself to try that and see if that is indeed the case. In any case, on day 0, when I start taking this is in, you start measuring the pH in stage 2. So the first stage, if you remember from my earlier discussion, is when you introduce water into your flax stalks. And the name for that stage is leaching. So you leave your flax in water for about an afternoon. And that is going to allow water into the stalks of the plant through the stomata along the stem. And it's also going to start removing water-soluble compounds from the flax stalk. So tannins, some carbohydrates, some nitrogen-based compounds, some coloring compounds are all going to come out in that afternoon in the leaching phase. After that point, you take your flax out, you drain your tank, and then you fill it again. And that's the pH that I'm measuring with that picture on the very top right. So I did my leaching on the afternoon of day 0. I started my ret on the evening of day 0 by putting my flax back into fresh water, and that fresh water showed me the tab on the top right. The next morning, which is my day 1 AM reading, I got the pH measurement that you see there. The evening, you can see we're mostly looking at the far right here. We're looking for pH numbers at this end of the scale, and so the first tab is not going to change. It's not sensitive at that range of pH. The middle tab is slightly sensitive, but probably not enough for me to really tell. But the combination of the rightmost tab and the middle tab will help me to tell on this litmus paper whether I'm at the right spot. So you can see that the color has changed slightly. It's probably gone down to about 6 or 5.5. I don't know, depending on the monitor and the light and all sorts of things, I find it really hard to tell exactly what the pH. I'm not an experienced pH reader, but to me that was reading at around 6-ish on the morning of day 1. On the evening or in the morning of, evening of day 1. Let me slow down. In the morning of day 2, I took my, when I changed the water, I tested the pH, and that rightmost strip was getting a little lighter. To me, that was around 5.5. I'm getting there. I don't have a photo for the evening of day 2 because my battery died and I couldn't take a picture. But on the morning of day 3, it had changed yet again. I was starting to see, I thought I could see a little more change in the center and on the right. The difference between day 3 in the evening and day 4 in the morning was the slightest to my eye. So they were approximately equal. I took that to be my level point at the base, and in combination with some other tests that I'm going to talk about in the next slide, I decided that it was time to pull this flax out of the retting pool. So that's using pH to help you. And again, you could only do this in a tank ret because the water is flowing too much. Any waste products are going to be dispersed in streams or ponds or lakes. So this isn't possible in that form of retting. So then you have to rely on your other senses and the tools that people used when they didn't have pH paper. So the first sense that I'm going to use when I'm going to check whether it's done is my sense of touch. So as the pectin is being eaten away and is being dissolved away, it coats the flax to a certain extent. And if you touch it, then your fingers feel slippery. I wouldn't say they feel slimy precisely, but you want it to be a little closer to the slimy end than the slippery end. So I have a video here. In a second, I'm going to frame it up so you can see my fingers. So I'm just rubbing my hands along the flax bundles here and then feeling them. And my fingers feel slippery. It's, it's not it's, sort of like a glycerin feel to your fingers. So my sense of touch is telling me that this flax is pretty close to being done. So the next sense that I'm going to use is my sense of smell. So the acids that are excreted by the bacteria, there's a number of them, but one of them is butyric acid, and the thing about butyric acid is that you can smell it, and that is the rotting vegetation smell that you smell when you walk by a ditch or a marsh. It's that smell of rotting vegetation. So your next test is to actually smell it. Now, it was a little ripe. It wasn't really horrible, but it did smell, did have that rotten vegetation smell to it. So that's another good sign that my RET is almost complete. The third check is a visual check. So I'm going to take a bundle out and I'm going to look closely at the stalks. And you can see that I can see some of the fibers coming away from the stalk already. So that is, now this particular test is one that you use both with ground retting and with any of your water retting methods, is to look at it and see if you see the flax separating. So the first two are tests that you do with any form of water retting, the touch and the smell, and you can use the visual check with ground retting as well to see the fibers coming away. Okay, so then you can also perform some checks when it is dry. So like I said, with my workflow, when I'm processing my flax, I will typically do a ret in the season that I plant the flax, and then sometime over the winter when I have a chance and the flax is completely dry, I will do the tests that you'll see here in these two videos to check if it truly is retted properly. And if it has not retted to my satisfaction, I'll set it aside to put in the retting tank or the retting pond or whatever method I decide to, or to leave it out on the ground to ret further. So the first, the tests involve listening to it and looking at it. So in the video on the left, the bundle is not quite retted enough. And so I'll show you some under-retted flax. And in the video on the right, that bundle is almost perfectly retted. So here I am with my under-retted flax. I like to take this 2 or 3 strands of flax out of the bundle, maybe from the middle and the edge, and I'm bending it. So this is an auditory test and a visual test. It will crack, it'll snap when it is properly retted. So this one, not so much. Now I take the flax and I wrap it around my finger. You can see it's like a ribbon. It just bends around my finger. That's a bad sign. This is under-retted flax. So this flax is going to be going back to be retted the next season. With that particular flax, I would say that flax is pretty much under-retted. I would put it back in my pond for probably about a week, probably at least 2 more days in a retting tank. If I were to continue the ground retting with that flax, that would probably be at least 2 weeks on the ground to ret that to where I like it. So quite under-retted. So this next batch, again, I take a couple of stalks out, and although I don't have audio available for you on this, I can hear it snapping when I'm listening to it. And you can see that it is more of a snap as well. The shards are breaking into points rather than just bending. So I'm pretty happy with the sound of this flax. So then I'm going to do my wrap test. And next time I make this video, I'm going to use a different color top so you can see it. But if you look at it wrapping around my finger, there's flax bits sticking out all over the place. That's what you want to see. You want to see the flax boon breaking into smaller bits and just sticking out all over. So for my third test, I'm going to be looking at whether the fiber bundles have started to separate or whether they're still laminated together. And so what I'm doing here is I'm just using my hands to strip away the boon from the fibers so I can look at the fibers that are left. And if it looks pretty solid, it's not quite retted enough. individual fibers are still stuck to each other. And like I said, it still looks laminated together. It's almost perfectly retted, but this is flax that I am not going to put back to ret again. It's too close. If I put it back even on the ground, it would probably be over retted. I can delaminate those fiber bundles using my hackles in the processing stage, and there will be a little bit more waste, but not as much waste as over retting the whole bundle. So that bundle is going to break and scotch very easily, and the hackling is going to separate the fibers. So I'm happy with that bundle. Now, going back to to my flax that I had been retting in the tank, where I was showing you the pH and I was showing you those tests when wet. It has since, parts of it have since dried. It's not completely dried, but there was a bunch of flax that just kind of fell on the ground during the whole process, and that has dried. So I picked up those few strands, and they don't pass my dry checks here. So those bundles that I did, that I was showing you with that pH, are all under-retted, and they're going to be going back in the tank. So this whole gamut of tests is really, it's really important to try all the different tests to see whether your flax is done before you decide that the flax retting process is complete. And I have my symbol to stop for questions. So, any questions?
Hi, Kat. I'm not sure. We just have one.
Okay.
Is it better to check the pH before or after changing the water?
I check it before I change the water, but I haven't tried it both ways. Given the fact that I under-retted this batch of flax, I don't use that method very much. It's a relatively new method to me because I just got my tank, and so I'm still experimenting with that particular form of retting and getting all sciencey about it. I might change it up and test the pH after I take the top layer of waste off, which might be skewing it more toward the acidic side. So do your own experiment.
Okay, another critter question. If retting on the ground, will animals like it?
Probably not. Because it would be like any animals, like slugs might like it. Like think of your garden. And if you have mulch in your garden, or if you have plants that are closely spaced in your garden, what is going to hang out underneath your mulch or underneath the straw? So you might get some slugs underneath there, but like nothing too scary, I don't think, because you are going to be flipping it every day. So you're going to be disturbing that environment.
Okay, and one last question. Does pond retting a problem for fish in a small pond?
In a small pond, it depends how small. So like I said, it's going to be making your water more acidic, and fish are sensitive to the acidity of the water. So it will have some effect on them. If it's a big pond, that's going to be spread out over a lot of water, so it's going to have a smaller effect. In a small pond, it will have a greater effect. I wouldn't want to ret in a pond that had fish that I wanted to keep in it. And as a matter of fact, that was one reason why a lot of people really hated flax processors back in the day when they were processing their flax in streams in large quantities. It was poisoning the water for fishing downstream, and people that relied on that fish for food were kind of pissed off because the stream became so acidic that the fish died. So I would say yes, it's going to have an effect on your fish.
Okay, another topic. Can rippled seeds be used for a second harvest now?
I don't know. It depends on your growing environment. So again, you can look at the 100-day window is how long it takes seed to grow from seed to fully ripe. And you can look at how long your flax grew in your own plat this year. And if you have a similar amount of time, you might be able to get another harvest in. Having said that, plants like to grow in different seasons, right? So peas don't necessarily like growing in the summer, whereas they're super happy growing in the spring. So planting flax now might slow the whole process down because the entire growing conditions aren't exactly what it likes. So for example, I know there's been some discussion that I've been following, people who are wondering whether they can grow flax in a greenhouse over the winter. And the advice that they got back is, well, it can, but it's going to take a lot longer for everything to happen in those conditions. So I would say that if you want all your seed to grow to viability, you're taking a chance by planting it now. If you don't really care, you're planning to buy new seed next season, then I would say go for it and try it out.
Okay, one last one has popped in.
Okay.
Have you seen differences in the flax color based on retting method? It gets mentioned a lot.
Mm-hmm. Have I seen it? Not, well, yes, I've seen it. So my ground retted flax ends up being grayer than my water retted flax, which ends up more golden. And I understand that snow retted flax ends up the most golden of all. And that is because the flax is weathering over the period of time that it's out. So if you think of a barn, a wooden barn, a brand new wooden barn has bright yellow wood on it, but as the weather and as it lives outside, that wood weathers to a gray. Same things happens with flax when it's laying on your ground. And the entire flax plant is stalks are going to end up looking much grayer than flax that you water retted. And that color is going to continue through the processing, so that flax from water retted gives you the golden flax color, and the ground retted flax will give you a grayer flax color. Having said that, those color differences disappear as you work with the flax and as the flax lives its life being washed and dyed and scoured and, you know, living as cloth. So for example, somebody who spun and plied and wove, spun and plied, water retted and ground retted separately so that they had golden yarn and gray yarn, and then use those yarns to try and to weave a color and weave effect using the gray and the gold, found that over time the entire cloth faded to an even ivory color, and you couldn't tell whether the flax started out as water retted or started out as ground retted. So given the passage of time, the color differences disappear.
Okay.
Long answer,
Well,
short question.
That was an incredible amount of work to find out the colors faded.
Yeah.
Someone is asking, would you repeat what the pH is supposed to do? Just what it starts at, goes down to, and back up before you harvest?
Okay, so the start is going to depend on your water source. It's going to be somewhere in the high 6s to 7s, depending on how sensitive your litmus paper is. It's going to go down to around 4.5 to 5 and settle there for at least 12 hours, maybe 24 hours. And then you're going to see that the numbers are going to start rising again. The rising number is your warning sign that you're definitely done with your ret. So you're aiming for 4.5 to 5 at the bottom end.
Okay, I have flax growing now. By mistake, I am letting it go to see what it does. It is 6 inches tall, growing fast compared to this spring.
Mm-hmm. So I think with it that height, you're well into the growing phase. I think you're going to find that it will grow into maturity before frost hits. I'm assuming you're in Ontario. If you're not in Ontario, then I'm not quite so sure of my answer. But around here, if it's at that stage, you're going to find it starts to shoot up, and you'll get some flax from that.
Okay, thank you.
Mhm.
Can you do litmus testing with ground method?
I don't think so, because you need a liquid environment, and you don't have that when it's ground testing. I think the litmus tests are pretty much only good for tank retting, where you have those controlled environmental situation.
Okay, thanks, Kat. That's all we have for now.
Okay, so I know I'm running right up against the hour, and I apologize for that. I will try to go a little bit more quickly through the ret. The last stage in this is to rinse after the retting. So you want to stop that ret when you think that it's done. So that means you want to get it out of the retting solution, and you want to clean off any bacteria. And this applies to ground retting as well, because you want to rinse it out. You want to rinse off all the bacteria that have been, well, not all of them, but some of the bacteria that have been helping you. And then you want to dry it as quickly as possible. You don't want to maintain your retting conditions at all. So I have a video of rinsing it, not because I don't think you know how to rinse, but to show you how gentle the water is. So flax that has been retting is still quite fragile. While it is true that linen yarn and linen cloth is stronger than when wet than it is dry, the opposite of cotton, that is not the case at the end of the retting process. So the act of it being submerged for so long, and to having been had the bacteria around it eating the pectin, leaves your fiber relatively fragile. After it dries, it's stronger again, and you don't have to worry about it shredding in your hands, but you do want to be careful right at the end of the retting period. So be gentle with your rinsing and slinging your flax around when it's completely wet. Oh, something flashed in my mind again. Oh yes, and another reason why you want to rinse at this stage is to rinse away any of that dissolved pectin that's still hanging around on your flax, because that will make your processing easier. The final information slide is storing your flax after retting. The most important is to keep your flax dry. So once you have retted it, you can store it indefinitely before processing, and like years, I'm talking indefinitely, as long as you keep it dry. So off the floor, if you're in an area that's prone to flooding. One winter I was keeping it in my shed in one of those brown bags that you see there, just sitting upright on the floor. And we had a late spring rain and ice storm. It flooded my shed and then froze everything in this sheet of ice at the bottom, restarted the retting process. By the time I was able to get into the shed, because the ice had blocked the door shut, it had re-retted and over-retted the bottom 6 to 8 inches of my flax, which just broke off during the processing. So keep it off the floor. If you're in a place that drips, keep it protected from any drips. If you're in a leaky old barn, make sure it's under in a place where it doesn't get dripped on. But having said that, don't put it in a sealed plastic container, because it does need some airflow. And if it's in a sealed plastic container, if there is any dampness, you might get mildew and you might ruin your flax that way. When you're storing it, you might want to support it so that it doesn't bow. Not really a consideration, but just for ease of handling. And if you're inclined to keep track of things, be sure you label it. So if you have different varieties of flax and you want to see the differences in the processing, remember to label it, so that you say, oh, well, this is my avian flax, or this is my Natalie flax, or this is my Richter's flax, or whatever, if you're keeping track of that. And you also want to keep track of flax that needs to be retted some more. So like my paper label that you saw in the picture ahead. Okay, so any final questions before I show you a quick tour of my first ret?
Hi, Kat. No, I think we're good. I think we're ready. We can move on.
Okay. So this is my first batch. I planted 3 varieties of flax. The first one the variety that I'm retting here is flax grown from seed that I had saved from previous years. I'm going to be retting also my avian seed in another batch and my Natalie seed in a third batch. So this is the first stage. This is the leaching stage. So this is the afternoon of day 0. I'm driving the air out of my plant and I am dissolving the water-soluble compounds. So in my tank here, I start here with rainwater because when I'm not retting in this tank, it's my backup rainwater storage, and I had water in it. So I used that for my leaching. I tossed the dry flax in. You can see how floaty it is. And so I used some lattice and some sticks that I tied together to just submerge it under the water. I don't care too much at this for the leaching stage, how deep it is, except that I want it all to be under the water. So after an afternoon, 4 or 5 hours, you take it all out and you can see the color of the water after. It looks like tea or very weak coffee. So those are the tannins and the coloring. And then I dump all that water out. It is of no more use to me. So I empty my tank and I start the developmental stage. So you can see in the top right picture, I am filling my tank from the hose. And the pH of the water is in the picture on the left, and the picture on the right is me with my thermometer. So where that tank is, it never gets above about 70 degrees. So it doesn't hit the ideal 80-degree temperature, but I don't really care. You can see that the flax is lower here. In addition to the lattice and the wood, I've added a brick to push it down further. That's to keep it below, to keep it well below the waste products that come to float on the top. So I leave it there overnight. So the developmental stage is the first 12 hours. So that goes from day 0 evening to day 1 a.m. And I don't know if you can tell from this picture. It was very difficult for me to take these pictures because even with a polarizing filter, you could see the side of my house. But the water looks different at the very top. You can see the waste products. First of all, you can see the little bit of foam, a little bit of bubbles. That's obvious, but the water looks viscous. It doesn't feel glycerin-like or like that pectin test that we were doing before, but you can tell that it's different, that it's not regular water. So you can see the waste. So that this is the stage when the anaerobic bacteria start. The aerobic bacteria did their thing overnight in the developmental stage. The start of this stage is when the anaerobic bacteria do their thing. They're breaking down the pectins and other compounds. And I'm going to be changing 10% of my water every 12 hours. I use a siphon in my case to do that. So I'm trying my hardest to just take the water from the top of the tank, and the pH is going to drop. Okay, so this is it. Any final questions before we come to the very end?
Hi, Kat. We do have just a few.
Mm-hmm.
Should you take pH before starting the ret?
Only if you want to see what your starting point is. So I generally would. So I can see what the start is and then when the pH starts going down.
Okay, and one last one.
Mm-hmm.
Could you submerge it vertically in a rain barrel?
You definitely could. And in a lot of, in Belgium, for example, I know that they had tanks where they put the flax in vertically and retted it that way. They had very elaborate tanks where they heated the water and maintained the temperature, but setting that aside, they did do it vertically.
Okay, thank you. That's all we have for now.
Okay, so if people are interested in litmus paper and going that route in a tank, I found Indigo Instruments out of Waterloo has great customer service, and they have both the litmus paper and the tabs. I also saw litmus paper at Sayal Electronics. I happen to have their bag here. This is what you get for living with a bit of a geek. They have locations in Toronto, Markham, Vaughan, Barrie, Mississauga, Burlington, and Cambridge. So you could just walk into their store. They sell electronics, but they also sell science kits for kids. And that's why they also have litmus paper for that. So Sayal, Electronics is another source for litmus paper, and beyond that, I'm not quite sure where you might find it. Okay, our next meetup is September 11th. We're going to talk about processing the flax. And here's just the reminder page. So I'll hand it back over to the OHS team.
Thank you, Kat, for your wonderful presentation and for being with us here this morning. We have all certainly enjoyed it. Thank you also to our participants for your interest and for your questions. Thank you to Pat Schaefer, the OHS admin, and for her admin support with these webinars. Thank you to OHS for their support of this web series. And please don't forget to mark your calendars also for the OHS conference running from October 21st to 24th. Thank you all for attending and have a wonderful day.